All right, we're going to go over the skill practice here. Are wages associated with marital status for US born 30-year-olds? So the null hypothesis is basically always that there is no association. The alternative hypothesis is that there is an association. We could say this a little different. We could say no association, meaning that the mean wages are the same. And the other one would be the mean wages are different. That's basically what association means, is that something is different. What's the mean wages for each group? Well, the app's going to find that for us. Randomization app to do the p-value. So let's do the randomization app to get the p-value. I already did the filtering. I'm going to look at 30-year-olds. I kind of changed a couple things. I wanted to look at just people who are working 40 hours a week and employed. I don't know if it said that for sure here. It never actually said employed. It didn't say working 40 hours a week. But I thought, let's try to make it somewhat equal. If we want people to be working 40 hours a week and employed, because maybe one group is less likely to be employed. We want at least each group to be employed and working 40 hours a week. So to use the app, we need to download the data as a CSV. And then we're going to come over here to stat key. We're going to go for a randomization test for the difference in the means. We're going to upload the file, upload the data file. They first want you to select the quantitative variable, which is wages, and then the categorical variable, which is marital status. So it's a key idea here that the variable that I'm looking at, that I want to compare the two groups, I'm only allowed to compare two groups. So if marital status is my explanatory variable, I have to make sure that there's only two groups left. Two groups remain, married versus never married. So that's what I've selected. And now it calculates. So what we have now here, if you look at this closely, we can see that the mean wages for married people are 125.71. So we could type that in here. So for married, it's basically 125K. For never married, it is what? It tells me right here. It tells me it's about 95,000. I'm estimating these. I'm just kind of doing this quickly because I'm making a video. So those are the two numbers. So basically we got about a 30K difference. And that's what's going to be called here. So that's what we care about. This becomes like the value of interest. It's just like when we did difference in sample proportions. The difference, when we're comparing proportions, we care about the difference. When we're comparing means, we care about the difference. So now that I have it into my data, I'm going to do a reallocation of the groups. So what this does is it'll take all of the different people's wages. So if you go back and look at this data, there's a lot of different values of wages. What it's going to do is it's going to take all these wages and it's just going to put them into two groups. So it's going to pretend wages are wages. We're just going to put them into two groups. We're not even going to name the two groups. We're just going to make two groups. So this is what it does. It creates two groups. The groups will stay the same size, 167 versus 139. And it's going to ask how big is the difference just by shuffling them up into two groups. Well, the difference now was 10,000. So we're trying to see, is 31,000 likely to happen just by randomization if you assume there's no difference in the groups at all. The only reason there's a difference in the group is because we randomly put them into two different groups. So we generate many samples, and we ask the question, how likely is it for us to get this big of a difference just by chance? That's what this randomization model assumes, because it assumes there's no difference between the means of these two numbers. So I do right tab, and I enter in my value here. I got a lot going on in my software right now. A little trouble here. Sorry, this is a pause in the situation. Oh. I need to pause the recording. Okay, my computer is just stalled up on this. I think it's just a combination of doing a video recording and running this app. This app does take up more space than everything else. How do I just pause this? Okay, well now it's letting me put a number in. I'm going to put the number in, hit OK. I'm going to go to the left side, and I'm going to also type a number in. And I hope it doesn't make us wait again. So sorry about this. You can run into this trouble. It's basically because I probably ran a lot of samples. Could be because I haven't turned off my computer today. Could be because there's a lot of other things happening in the background. Because the combination of the IEL data and this randomization test and the fact that I ran 9,000 samples starts to load up my computer pretty fast. I wish I could pause this. I'm sorry. Okay, let's see. Maybe it's going to open up for me now. Apologies. Okay. Okay, well, I would normally retype it in over here, but because of the time that it took, I don't want to do that. But you can basically see very little red. If we added these two together, now this is not the exact number because I don't have this number in exactly right, but it's pretty dang close to the exact number. If I add these together, I get 0.035. So my p-value here is 0.0035, right? That is equivalent to 0.35%. This is really low. It is indeed less than this 5% that we call our significance level. So it's way below our significance level. So we're going to make a conclusion. The conclusion is that the difference is statistically significant. Sometimes you'll say, like, we'll say the evidence is strong enough to allow us to rule out natural variability in sampling as source of the difference in means. Meaning that we're seeing a difference in means because there actually is a difference in means between the married and the never married 30-year-olds that are working 40 hours per week. There is a difference. There's something different about these two populations that make them earn different average wages. So we can say the means are different. So we do have the wages are associated with marital status. Use Bootstrap and determine how big the difference is. Sort of afraid to do that, but I'm going to close this app. I'm going to close the ACS data because that will help us out a little bit. And what I'm going to do now is show you the new app. So I'm going to go into StatKey again. I'm going to do a Bootstrap confidence interval now. I'm going to upload the file. I'm going to select wages again and marital status. Calculates the two numbers here. Now what this is doing, this is bootstrapping. So bootstrapping is using the individual data for each group and just reselecting them. It's called sampling with replacement from the original data for each of the two groups. So the values will change, but they won't change by a whole lot. I mean, you can see there is some change. I mean, as we do this, you're going to see these numbers will deviate a little bit from what the original value was, but not too dramatically. And every time we calculate the differences, you can see the differences. It appears that every time you do it, very seldom was the never married group going to be bigger than the married group. Like here's an example actually right here. If you look at this example right here, that the two groups are different, right? I mean, you can see all this over here at the 0 means that the never married group is larger than the married group. But that doesn't mean that much because it only happened very few times out of 6,000. So what I do here is I click two-tailed, and this tells me that based on my sample data and the difference that I observed of 31,000 between married and never married, I can, with 95% confidence, say that the true difference in mean wages between these two groups is going to be at least about 10,000, and it could be as high as 52,000. Means there's just a lot of variability in this data, mainly because we're dealing with sample size and we're dealing with very big numbers. So these large numbers and the large range of values kind of combines together to create very lot of uncertainty. You can almost say this uncertainty is almost like plus or minus like $20,000. because the sample statistics showed 31, but it could be as high as 52, could be as low as 10,000. But definitely married people are making more money than never married. How much more on average? We're not sure. Somewhere between 10,000 and 52,000. All right, thank you. Sorry for all the slow computer time.